Okay, we're talking about chemical reactions now. And chemical reactions are rearranging chemical bonds. That's all they really are. It's just taking one chemical and changing it into something else. Its reactants will interact to form products. So the reactants are the things on the left. So we have the reactants, and they rearrange to form products. Chemicals you start with before the reaction, those are the things that react. Products, chemicals you end up with after the reaction, expressed using a chemical equation. This is in table 11.1, page 323. You don't have to write this down. Plus is used to separate two reactants, two, not toe, or two products. This arrow sign, people know that means yields. That's what it forms to, or the reactants go to. So it separates reactants from the products. Now this double-sided arrow shows a reversible reactant or reaction. That means these reactants can become the products, and the products can go back to the reactants. So it can go either way. Little s in parentheses just means that's a solid. The reactant or product could be a solid. So if we had solid salt, NaCl, if it was the solid, it would be an S. Now L means liquid, so if we have H2O, liquid, as opposed to solid, solid liquid, or excuse me, solid water. G means it's in the gas state. So you might have gas, water, or oxygen gas. Now, aqueous means it is dissolved in water. So, for instance, we might have sodium chloride, but if it says AQ, that's not the solid sodium chloride. It's the sodium chloride dissolved in water. Now, these things are symbols that are above the arrow sign. Either a triangle or heat means heat is supplied. So if you're using the Bunsen burner and you're writing a reaction with that, you would have heat above that chemical reaction. If you have some sort of a chemical above this arrow, this means a catalyst is used, and we'll go much more into catalyst later, but a catalyst is just something that helps move a reaction along. Okay, in this example, the catalyst is platinum. We have the reactants and the product, and we have coefficients here. These are coefficients. Coefficients just means, this means two hydrogens. So there are two of these. There's none here, or there's actually, if there's nothing here, we assume there's a 1. So that's plus an oxygen yields 2 waters. This big 2 means there's 2. Now we're going to look at balancing chemical equations. This is actually fun stuff. It's like a game. I know a lot of you guys play Sudoku, as well as your little EC parties. But these are really, actually can be pretty fun. They can be pretty difficult too, pretty challenging. Balancing chemical equations, the goal is to have the same number of atoms or polyatomic ions on both sides of the equations. So whatever you start out with, you must end up with. There's a conservation of mass. You start with a certain amount of mass, you have to end with that same exact amount of mass. Now there is Einstein equals mc squared, where mass can be changed, but here for us, we are just looking at if you start with the same mass, you have to end with the same mass. So that means when we balance equations, for instance, this iron, there's the same number of irons on this side must be equal to the same number of iron here. Here we see that's not the case, so we have to balance it. Conservation of mass. We can't have different amount of irons. And oxygens have to be the same that we start out with as what we end with. Now they might be in different form, they might be in different compounds, they might be in different molecules than what they start off with. That's of course because of a chemical reaction. But there has to be the same number of oxygen, there has to be the same number of iron that we started out with. Now, how do we balance this? Well, we do so by changing coefficients, not the subscripts. So the coefficients are the big numbers that we put in front. For instance, we'll put a 3 or a 2. We can't say, well, there's 1 iron here and there's 2 iron here. Well, okay, why don't I just, I don't know, let's get rid of this iron. Yeah, it's balanced. And there's 3 here and there's 2 here. I'll just change that to a 3. Hey, it's all balanced. Yay. No, you cannot do that. You have to add big numbers, and that's where the challenge comes in. So what we're going to do is add the big numbers to it. And we have it balanced because now, and we'll show you how to balance these equations in a bit. I'm just going over what this basically generally is. So we have 4 irons on this side. We have 4 irons here because we have 2 times 2. We take this coefficient, this big number, and we can multiply it through everything. So that's 4 iron here. Now we have 3 times 2, that's 6 oxygens on this side. And we have 2. Now this belongs here as well. 2 times 3. So that means we have 6 oxygens there, and we're all balanced and happy. Because we start with 4 irons, 6 oxygens, we end with 4 irons, 6 oxygens. So let's try some of these. When you're doing these, you want to start with the most complicated one and then end with the most simple one. So let's first just look at, let's just count the number of molecules of each, or the number of atoms of each. So we have 1 tin here on this side and 1 tin there. Those are balanced. We have 2 hydrogens there and 2 hydrogens here. Those are balanced. Well, it looks like everything is balanced. 2 oxygen here and 1 oxygen there. So we have to balance the oxygen. And we start with the most complicated one right here. And so there's 2 there. Well, we'll add a 2 here. So that's 2 oxygen here and 2 oxygen there. Those oxygens are balanced, tins are balanced. But the hydrogen, 2 times 2, that's 4 hydrogens. There's 4 hydrogens here. And we'll leave this one. That's easy. We just put a little 2 there, and there's 4 hydrogens. We're balanced. Everything's good. And we didn't have to do anything with the tin. The tin just stayed. Now the reason we leave the easiest for last is because, or the simplest for last, because if we put something there, and if we had to put something in front of the tin here, it doesn't change anything else. Whereas if we had to put something here, it would change the tin and the oxygen. So we wait until the end, and we'll wait for the least complicated one to do. Okay, let's try this next one. Now, if you notice, here is a polyatomic. You really have to identify these polyatomics. This is also polyatomic, but there's no OH, hydroxide, on the product side. So we see a PO4 here and a PO4 here. Treat the polyatomics as though they're just one thing, one little entity. Okay? Don't break them up and count them down. Treat them as though they're one, because it gets much easier that way. So there's one PO4 on the product side, and there's one PO4, I'm sorry, on the reactant and the product side. There's one H here, and there's 2 H's here. Nope, I am incorrect. See, I didn't count this. This is 1H and 3H. There's 4 H's there, and there's 2 H's here. There's 3 K's and 1 K there. Let's start with the most complicated. Let's change the K here. Let's just put a 3 here. So this is 3 Ks. So that makes it 3 potassiums and 3 oxygens. And now we have 3 hydrogens plus 3. That's 6 hydrogens. And we have 2 hydrogens that side. Everything's balanced. We have 1 oxygen here. So if we put anything in front, it's going to change the hydrogen and the oxygen. Let's put a 3 here. So the 3 multiplied by the 2 makes this 6 hydrogen. That's good. That's what we want. And then makes it 3 oxygen. Everything is balanced. Looking good. Okay, and that's all we had to do. And notice we didn't have to do anything with this, the polyatomics here. They just stayed the same as a group. Now, if we had to break it down and multiply out 4 oxygens plus the 3 oxygens, that would have been kind of a nightmare. So keep the polyatomics together. How about this side down here for this reaction? Okay, we see that there's a polyatomic here, and then 3 polyatomics there. So that's 3 SO4s. And 1 SO4 on that side, and there's 3 SO4s on this side. 2 hydrogens on this side, 2 hydrogens. Hydrogens look good, and 2 irons, and 1 iron here. Okay, now let's do the most complicated one first and keep the most simple for last. This is the most simplest. We can use that. Now the hydrogens are balanced. Let's balance the sulfates. So put a 3 there because there's 3 sulfates here, so we'll put a 3 here. That makes it 3 sulfates, but it makes it 6 hydrogens. So to make 6 hydrogens here, we'll put 3 there. Now, only thing that is not balanced is the iron. And that's easy. Just put a 2 here. You really love to see elements that are all alone by like this, like metals. All alone, not even a subscript, because you put something there, it doesn't change anything. I can put anything there, and it won't change anything. They're very easy. So that's you love to see these things. Okay, that worked. It just takes practice. Keep doing it over and over.